Hello everyone, welcome to the purple classes of the Res Indica IS Academy, Desh Badla Padhai Badlo. Today we will be talking about again yet another a very important topic on science and technology, that is space. Okay, so this lecture is also being distributed into the two lecture series. In the first lecture series we will be understanding some of the very basic part of that. What is the meaning of space, what is the meaning of space technology, then what is the meaning of orbit, then various type of satellite application, then what type of rocket launching vehicles we are having in our country. And in the next lecture we will be discussing about all the application part of this whole lecture. Okay, so let's start with our session right away. So this is Indian economy, science and technology, space part 1, and we are right now discussing this awareness in the field of science and technology. We have already completed the biotechnology part, and right now we are doing the space part. Okay, so let's start with our session. So in India, space program is a highly commendable space program. Since 50-60 years, India is on the top 5 countries which is having a lot of successful mission on its pocket. Okay, so in India, the normally our space program as we are being run by Indian Space Research Organization, which we call it as ISRO. And here, what exactly is the role of this space organization? That first of all we should come to know. Okay, because ISRO comes under the Department of Space, and Department of Space, Government of India is directly taking care of the space programs of India, and ISRO is the leading organization which is taking care of all the important space mission of the country. Okay, so the ISRO, if we go by the foundation part of it, so ISRO was founded in 1969. Okay, right, the main purpose is that we have to follow, we have to go and harness whatever the space technologies are there, and how we can utilize these space technologies for our own national development, and how we can leverage these science and technology of the space sector, and how we can make and do research exploration, scientific research in all these areas, and how it is useful for the benefits of society and global world in large. Okay, so if we go by the objectives of our Indian space program, first of all it is of the national development, how we can utilize the space technology in the help of socio-economic development, like we are utilizing various type of satellite which are earth remote sensing satellite, then we have our own navigation satellites are there, we have our own communication satellites are there, right? How we can utilize for mapping the resources, urban setting, then rural settings, and how we can helpful in environmental monitoring. Okay, like socio-economic development, we have to find out like rural areas, urban areas. Right now the assets are being geotagged. Okay, the geotagging is done with the help of the satellite data. Okay, then resource management, like if we wanted to find out what is the what we are having, the bio lifestyle is there. Okay, like we have flora, right, trees, vegetation. Okay, how we can find out like what is the cover of vegetation in our country, whether it is decreasing, whether it is increasing. This we will be able to help with the help of a satellite data. Okay, then environmental monitoring, like how we are going to benefit and how we can monitor our environment regarding the clouds, rain, cyclones, and various type of disaster we can monitor from the space itself. Then the next objective is space exploration, like there are a lot of technologies are being utilized for the further deep space research. Okay, lunar research, like regarding like we are sending our satellites to the moons. Okay, for research right now, Chandrayaan 1, 2, 3 are there, which are the lunar mission, and even the world is being looking forward for that. Okay, right now we have done a very remarkable landing in the lunar surface on the south pole of the lunar surface, right? Then interplanetary mission, right now we have done Mars orbiter mission we have sent, MOM mission in 2014 we have sent, right? And satellite explorations are there. Then strategic application like regarding the national security, like we are utilizing GPS system, we have our own NAVIC system is there, okay? And then we are utilizing the GSAT satellite. GSAT satellites are there, which especially focus on our communication and mapping the area and helpful in disaster management and also finding out the various type of resources at various places. So these are all the important objective of our Indian space research program. Okay, now if we go by the story of the Indian space research program, it like if I go by the what we call it as in a timeline frame, okay, in August 15, 1969, ISRO was officially created on the Independence Day, 15th August 1969, okay. Then they have created on 1971 October 1 SHAR center, now SDSC center, that has been operationalized in Sriharikota, okay. From Sriharikota only maximum launches are taking place, right? Launch of the satellite usually takes place. So, most of the satellites takes place from Sriharikota. Then India launches its first Indian satellite, that is called Aryabhata, on April 19, 1975, right? Then came January 1st, 1977. Then we have sent a telecommunication experimental satellite that took TV to the villages, okay. Then June 17, 1979, Bhaskara satellite for Earth observation has been sent in 1979. Okay, then India has experimented its own launch vehicle, that is called satellite launch vehicle SLV-3 during that time. Okay, we will be discussing in detail about that. Okay. Then in 1981, ISRO first communication satellite using Arena space rocket. Okay, again we have taken that from leased it from the other countries. Then we have launched our own advanced SLV satellite, that is called Advanced Satellite Launch Vehicle, so ASLV. So again this we will be discussing in detail. All the launch vehicle we will be discussing in detail. Then first launch of polar satellite launch vehicle, and which is the most successful series of India's launch vehicle, that is polar satellite launch vehicle, came in 1993. Okay, then in 2001, geosynchronous satellite launch vehicle GSLV satellite, GSAT satellite 1 has been put onto the orbit in 2001, and then launch of Chandrayaan 1 in 2008, and Mars orbiter mission in 2014, and in July 15, 2019, Chandrayaan 2 has been sent, but the rover part of that got failed, and the part which is like orbiting orbiter has been still working over there. Chandrayaan 2, okay, here if we go by that, Chandrayaan 2 lander got failed, but orbiter is functioning, and this Chandrayaan 2 orbiter data is being utilized by Chandrayaan 3, okay, in which both lander and orbiter became successful last year. Okay, and then after that, India has even sent our Aditya L1 satellite. Aditya L1 satellite has been sent to Lagrangian point 1, okay, which is the place between Sun and Earth, around 1.5 million kilometer. Okay, that is 1% of the distance of Earth from the Sun. Okay, 1.5 million kilometers, right, has been sent, and now it has already reached at the Lagrangian point, okay, last year. Okay, so these are the big missions that has been sent by the Indian Space Research Organization. Now we are coming into the concept of what is the meaning of orbit, because every satellite, whenever we say, we always come and heard about the word what is the meaning of orbit. So orbit, whenever we say orbit means it is a regular path which is being taken by the satellite around each other. Okay, so if we go by the concept like what exactly is that path, it is called, so orbit is a curved path that an object in space such as stars, planet, moon, asteroid, spacecraft, whatever it is, they takes around any other object due to gravity. Like if we go by the example, like if we have this thing, okay, and if something is revolving around them, okay, so this is a orbit, this is a orbit, okay, and there is one object which is orbiting around this body. We call this as satellite, okay, and this is earth, okay. So the satellite is revolving around the earth in a orbit, right? So gravity, what is the main reason why these objects moves into orbit? The main reason for the objects are moving into each other orbit is because of the gravity through which they attract each other towards themselves, okay. So gravity causes objects in space that have mass to be attracted to other nearby objects. So if this attraction brings them together with enough momentum, they can sometimes begin to orbit each other, okay. So object of similar mass orbit each other with neither object at the center, while smaller object always orbit around the large objects. So in our solar system, you might be knowing moon orbit earth and earth orbit the sun, but that does not mean that the large object remains completely still. Because of gravity, earth is pulled slightly from its center by the moon. Because of that only the tides form in our oceans, right? And our sun is pulled slightly from its center by the earth and other planets. So during the early creation of our solar system, we know that dust, gases, ice all traveled into the space with a speed and momentum. Okay, everybody is having speed and momentum. Okay, surrounding the sun in a cloud form. So with the sun being at much larger body, sun is having much larger body, 99% of the mass of our solar system belongs to sun. That these small bits of dust and gases, because of the gravity, got attracted into the orbit around the sun, okay, shaping the clouds into a kind of a ring around the sun, okay. And eventually what will happen? These particles started to settle and clump together or coalesce, and they are even growing much more larger like a rolling snowballs until they form what we call now as planet, moon and asteroids. So the fact that the planets were all formed together, that is why all the planets have orbit around the sun in the same direction, in roughly in the same plane. So whenever our rocket launches our satellite, whenever we launches our satellite or rocket launches a satellite, we put them into a orbit in the space, okay. So there is a gravity which keeps the satellite on its required orbit. That is because of the gravity which keeps it into a required orbit. In the same way that gravity keeps the moon in orbit around the sun, and the same gravity keeps the earth around the sun. So this happens in a way that is similar to throwing a ball out of a window of a tall tower, okay. Like if I wanted to explain you like this, like if we have this tower and we are throwing a ball like this, okay, the ball will fall on the surface, okay, this ball fall in the surface. If we are throwing the ball with some more speed, okay, again it will fall on this surface. If we are throwing the ball with one more speed, slowly this ball will come into the circular path, when it will keep on trying to fall, but because of the gravity it will not able to fall. Like I just give you one more better diagram, okay. Here what is showing is that if we have this surface, okay, this is a surface, from here we are throwing something, we throw a ball, it hits here, we throw a ball with a greater momentum, it's hit here, we throw a ball with a greater momentum, it hits here, we throw a ball, it comes into the circular orbit like this, okay. So this is what the speed that is needed in order to make something to orbit around our earth. So similarly it is for all different planets, that how we wanted to work it, okay. So this is what happens, is similar like throwing a ball out of a window of a tall tower. So to get a ball going, you need to first give it a push by throwing it. making the ball fall towards the ground on a curved path. And we try to keep on increasing this curved path until and unless the ball comes in orbit with the earth. Whenever ball is trying to fall onto the earth's surface, the gravity is not allowing the ball to move to the surface. Okay, in the similar fashion, the satellite is also put into the orbit by providing a push through a rocket. Okay, satellite is being put into the orbit by providing push from the rocket. Okay, we see the rocket going very high, and there it is releasing the satellite with the help of their motors. Okay, first of all the rocket will bring that satellite to a certain desired location. Like the rocket is trying to act like a releasing tower. Okay, the rocket is act like a releasing tower. When the rocket has reached at a certain height on the earth's surface, it releases the satellite with certain speed in that direction. Okay, it leaves that satellite in that direction, so the satellite will come in orbit of the earth surface. So this is what the working is that. Okay, so as you all know that similar fashion, satellite is put into the orbit by placed being thousands and thousands of kilometers above the surface of the earth. That means we are thinking like a very tall tower. Okay, and there we are trying to give a push by a rocket engines to make it start on a orbit. Okay, I hope you got it. So the difference is that throwing something will make it fall onto the curved part. But if you are providing them with a really powerful push, they will come in orbit of the earth. They try to fall indefinitely to the earth's surface, but because of the gravity, they will not fall onto the earth's surface. So that means we have reached an orbit. Okay, so why they keep on moving without any fuel in the outer atmosphere, in the outer space? Because there is no air and there is no air friction. Okay, there is no air and friction that is there onto the space. Okay, so once we follow the Newton laws of motion, which says that until and unless any external force is applied on it, the body will continue to be at rest or at motion. Okay, so since we have provided a motion, so the body will keep remain in motion until and unless we provide some external force to stop it. So the body will indefinitely move in that circular orbit or your elliptical orbit like that. Okay, so in space there is no air and there is no air friction, so gravity lets the satellite orbit around the earth with almost no resistance at all. So putting satellite into the orbit enable us to use technologies for various type of purposes like telecommunication, navigation, weather forecast and astronomical observation and many other things. Okay, so now people comes to understand like what is the shape of orbit. It is always really oval or any other. So there are lot of orbits are there. You can have a elliptical orbit, you can have a oval orbit, you can have a circular orbit. Okay, based on the varying eccentricity, you can have various type of orbit based on the type of requirement that you are having. Okay, so if we go by the process like planetary orbits, they normally tends to be nearly circular. They are nearly circular but slightly elongated from the outer edge. And the comets which are taking the orbit, they are highly eccentric or elongated. So whenever the comets comes, they have a highly eccentric, highly elongated orbit was there. But planetary orbits are more or less near, they are circular in nature. Sometimes they have a slightly elliptical orbit, like our earth has a elliptical orbit is there. Okay, so now since our earth is revolving around sun. Okay, so if we see, this is a sun and our earth is revolving around the sun. Okay, so there are 2 points at which point earth come closer to the sun, and here earth is farther from the sun, right? So when we call it as the closer means perigee. This is called perigee position, and farther position is called apogee. Apogee positions. Okay, so planets have a perihelion, that is close to sun, and aphelion, that is farther from the sun from their orbit. Okay, and what is that orbit period is called? So orbital period refers to the time taken by an object to complete one full orbit. Like if the moon is taking orbit of the earth, if the earth is taking the orbit of the sun, okay, that is called orbital period, right? So our earth has an orbital period of 365 days, right? That's what. But only there are again certain few things are also there that has to be coming in the coming future classes. Okay. Then there is a inclination, denotes the angle of orbital plane concerning the earth equator. Like we have seen that the earth is like that and earth is inclined like this. Okay, earth is not straight. Okay, so earth is inclined like this based on their angle with the earth's equator. So there is also an angle of inclination. Because of that only we are having varying degree of sunlight at various places on the earth, and we have the various type of seasons that are there in our country. Okay, now what is the mechanism of orbiting that is being utilized over here? Okay, so we have already discussed Newton's first law has been utilized for orbital motion. Okay, so anything will remain in motion until and unless acted upon by the external force. Okay, so satellite keep on moving until we and go and stop it, or we provide some kind of force to stop it, right? Gravity is the very important role that is which keeps the satellite into the orbit, and which keeps the satellite attracted towards the surface. Otherwise the satellite will go deeper into the space because there is no force which is controlling it. It is the gravity which is attracting the satellite towards itself. Because of that only it is revolving around the heavenly bodies. Okay, and orbit occurs when a forward momentum of an object balanced with the gravitational pull. Okay, that means if the satellite is going like that and gravity is attracting like this, so this motion will get bend like this. Okay, this motion will bend like this and start rotating like that. Okay, otherwise if the satellite is going like that and there is no force, so a satellite will go deep into the space. But yeah, because of the gravity, this motion will get tilted towards the surface and this will come into the circular orbit. Okay, so this is the velocity that is there, and it will also help in preventing the collision. So orbital velocity is crucial for staying in the orbit. Okay, so there is a proper velocity that has to be provided, like at what velocity, at what height the satellite has to be put in order to balance out the velocity of the satellite and also the gravitational pull of the earth. Okay, so right, if we wanted to, like for instance, if we are putting satellite at 150 miles above the earth surface, so we need it to go around 17,000 miles per hour of the speed. That is what one example that we have taken. So there, for every height the velocity is being defined, which will cancel out and which will balance out the earth gravitational pull, and it will remain in orbit like that. Okay, so here you can see we have these layers of the atmosphere are there. We have a troposphere till 10 kilometer, then stratosphere up to 20 kilometer, mesosphere, then thermosphere, then exosphere. Normally the satellites start from here in the mesosphere and thermosphere level, and it goes way beyond above that. Okay, and normally all these activities like airplane movement, because airplane takes place of 33,000 feet, which is close to 10 kilometers, okay, at the height. So it is in the troposphere. Some spacecraft normally travel in stratosphere. Okay, and rest above mesosphere and thermosphere, normally most of the satellites are usually being put, and communication satellite are being put thousands of kilometers away from the surface of the earth. Okay, now there are various type of orbits are also there. Okay, so that now we will be studying. So once the satellite is launched or the spacecraft has been launched, it has to put on a particular orbit. Okay, so you are sending either to interplanetary mission, Okay, interplanetary means now the satellite will not be revolving around the Earth. It will be revolving around some other Mars, Jupiter, or Sun, or various other planets, or Pluto, or whatever it is. So Pluto is not a planet right now. Now it is a dwarf planet. Okay, so there are various factors that has to be decided, like what is best for the satellite and what type of orbit in which that satellite has to be sent. Okay, so we have lot of satellite orbits are there, like the satellite can be sent into the geostationary orbit, satellite can be sent into the low Earth orbit, satellite has to be sent either can be sent into a medium Earth orbit, satellite can be sent into the polar or sun synchronous orbit. Then we have a transfer points, and then we have a Lagrangian points are there. So these based on the application and usability and feasibility and costing, we define in what type of altitude or what type of orbit we have to send our satellite. Okay, now we have the first orbit, that is called geostationary orbit. Okay, now under the geostationary orbit, whenever we say what is the meaning of geostationary orbit, like if we are sending the satellite to the geostationary orbit, so that means the satellite will circle the equator. The satellite will be placed above the equator. Okay, satellite in geostationary orbit circles Earth above the equator from west to east, and they follow the Earth rotation. That means 23 hours, 56 minutes and 4 seconds. Okay, so they will be traveling at the exact same rate as Earth. Okay, so because since the satellite is also traveling with the same rate of Earth, so relative velocity becomes 0. So you will see that the geo satellite will observe as stationary over a fixed point. Okay, so in order to perfectly match the Earth rotation, the speed of geo satellite should be kept around 3 km per second, and that too at an altitude of 35,786 kilometer. Okay, 35,786 kilometer it has to be kept, and at approximately 3 km per second, then only our satellite will be able to properly match the orbit of the like the rotation period of the Earth. Okay, so geo satellites is used the need to stay at constantly above the particular place on the Earth. Okay, so whenever there is a satellite that is needed, that has to remain at a particular position above the surface of the Earth, especially telecommunication satellite, that we are asking, they has to be remaining at a maintain at a bilkul proper fixed position at the surface of the Earth, because they have to point out towards the antenna. Okay, if the satellites keep on changing its position, so antenna also has to keep on change position, so it will not create any kind, it will create a lot of disturbance in the signal. Okay, so that is why geo is primarily utilized when satellite requires constant coverage over a specific location. Okay, so they maintain a fixed position relative to antenna. Okay, so this way an antenna on Earth can be fixed to always stay pointed towards the satellite without moving. So you might have seen that your Airtel TV, okay, Tata Sky, okay, normally they point the sky in particular direction. Okay, they point the sky in particular direction. Though always whenever somebody comes to install Tata Sky or anything over there, they point at certain direction. Your dish has been pointed. It cannot be pointed everywhere. It has to be pointed at certain proper direction. Okay, so that is because they are directing towards the geostationary orbit and geostationary satellite. Okay, so we are fixing the antenna like that. So it can also be used by weather monitoring satellite, because they can continuously observe a specific area to see how weather trend emerge there. Okay, like if we are keeping the satellite over Delhi, okay, So since 24-hour, it will give us whole data because it is totally stationary at that point, and we will come to know that what was happening to Delhi within these 24 regarding the vegetation, regarding the weather patterns, or whatever it is. Okay, whatever it is, right? So satellite in geostationary orbit covers a very large area. So as few as 3 equally spaced satellite can provide near global coverage. That means if you want a whole global coverage, so if you are placing 3 satellite accurately, if you are keeping 3 satellite accurately, you will be more or less covering the whole global area. You will be covering, because this is because when a satellite is this far distance, that means 35,000 kilometer, 786, it can cover large section at once. This is akin to being able to see more of a map from a meter away compared with it you were a centimeter from it. Okay, so to see all the earth at once from a geo, far fewer satellites are needed at a lower altitude. Okay, so this is regarding the geostationary orbit. Okay, so this is about the geostationary orbit. So here you can see this is equator. The geostationary satellite space just above the equator at 35,786 kilometer, and if 3 equally spaced satellites are being utilized, so they can map the whole world. We can map the whole world with the help of these 3 satellites. Okay, so here you can see we have a satellite with the Earth, which is being put at a 36,000 kilometer distance. Geostationary orbit is there. Okay, and they normally keep their wings towards the sun in order to provide continuous power through the solar panels. Okay, so typical mission is like 5 to 10 times lower than the like normal equivalent fluorescence is 5 to 10 times over here, and they keep on pointing towards a certain location throughout the world, and this is very important, especially for the communication satellite. Okay, now comes the low Earth orbit, LEO orbit. So this low Earth orbit has a certain places, like between 160 kilometers from the surface of the earth up to 1000 kilometer above the surface of the earth. Between this we call it as the lower Earth orbit. Okay, so geostationary orbit satellite has to orbit around the equator, but LEO satellites are not restricted that they should only focus on equator. They can be tilted anywhere. Okay, they have a tilted plane. That means they have their own angle of tiltation, whether they can move towards the crossing polar or equator, whatever, wherever, based on the application, they can be put anywhere. Okay, so low Earth orbit satellite orbit at a very relatively distance close to the earth. So if we try to compare, most commercial aeroplanes do not fly at altitude much greater than 14 kilometer, right? Normally the commercial aircraft fly is just around 14 kilometers. So even the lowest LEO orbit is 10 times higher than that. That means they are like, if the commercial flight is running at 14 kilometer, so if you do 10 times of that, 140 kilometer, still you are not reaching the LEO orbit. Okay, so 10 times above that only that satellites usually move. Okay, so unlike satellite in the geo, they must always orbit. LEO satellite do not always have to follow the particular path. Okay, your plane can be tilted. They can be tilted in any plane. This means that there are more available routes to the satellite. That means there are more routes are there. Okay, they can move like this, they can move like this, they can move like this. Okay, whatever the way they wanted to move. Okay, so this means okay, which is one of the reason why LEO satellites are commonly used for orbit, because they don't have to focus on certain area. Okay, so LEO satellites are having a very close proximity to the surface of the earth, right? So close proximity to Earth make it useful for several reasons, because the Leo orbit is very close to the Earth's surface. So it is the orbit most commonly used for satellite imaging purpose. Okay, because they are being nearer to the surface, so they take the images very of high resolution quality. It is also the orbit used by the International Space Station, that we call it as ISS. Okay. I think it is around 400 kilometers from the surface of the Earth, which is 250 miles from the surface of the Earth. That is 400 kilometers from the surface of the Earth. So it is easier for the astronaut to travel to and from this shortest distance. Okay, so satellite who are orbiting at this orbit, they normally travel at 7.8 kilometer per second. Okay, 7.8 kilometer per second they are traveling. 7.8 kilometer per second is the orbital speed that they are taking over there. Okay, so at this speed a satellite takes around 90 minutes to circle the Earth. 90 minutes. That means ISS travel around the Earth about 16 times a day. Okay, so for one orbit they takes around 90 minutes. 90 minutes they take one round, so around 16 times. If we go by that, ISS revolve around the Earth around 16 times a day if they are in this orbit. Obviously they are in this orbit. Okay, so they are utilized for high satellite imaging purposes. International collaboration like ISS are also being there, and then OneWeb constellation is also going on over there, where India is also participating in this whole process. Okay, so however, individual LEO satellite are less useful for telecommunication task, because they move so fast across the sky and therefore require a lot of effort to track from the ground station. Okay, so we do not normally put communication satellite at this orbit because they move so fast, 7.8 kilometer per second, that it is very difficult, or it takes a lot of energy, lot of efforts to track these satellites from the ground station. Okay, so instead the communication satellite in LEO often works as a part of large combination of constellation. That means if you are putting any communication satellite at this LEO orbit, so you have to put large number of satellite over there, large number of satellite like OneWeb communication. Okay, Starlink satellite, which your Elon Musk is making, right? So we require large number of satellites over these area if we wanted to go for a communication satellite, because multiple satellite will give constant coverage. So in order to increase the coverage, sometimes constellations like this, consisting of several or similar satellites, are launched together, so they create a kind of a net. Okay, they create a kind of a net. So this led them to cover the large surface of the area simultaneously by working together. Okay, so this is how, if we wanted to put communication satellite at this LEO Earth orbit, we require constellation of multiple satellites that are to be developed so that they should work continuously and in combination with each other. Okay, so this take one orbit every 90 minutes, orbiter like this around from 160 to 1000 kilometer, and we have ISS which is at 400 kilometer from the surface of the Earth. And if we wanted to put communication satellite at that level, so we need multiple constellations of the satellite has to be placed so that they should work all together to provide better connectivity. Okay, now we are moving into the medium Earth orbit. So what is the meaning of medium Earth orbit? So medium Earth orbit is from 2000 to 35,786 kilometer. That means above LEO and below your geostationary orbit. Okay, so between LEO Earth orbit and geostationary orbit, we have a medium Earth orbit which is there. Okay, like that, between that. So this will also having and providing us with large amount of coverage. So medium Earth orbit comprises a wide range of orbits. So there are wide range of orbits are there between this range 2000 to 35,000. You can put satellite anywhere between that range, right? So it is similar to the LEO, is that it also does not need to take any specific path. That means this satellite does not require any specific path. You have to put you can put it in anywhere. Okay, you can put it anywhere. Okay, so that is why there are a variety of satellite which have many different application based on that. Okay, normally the focus of this medium Earth orbit is navigation satellite. Okay, like we have a European Galileo system is there. Okay, so Galileo power navigation system is there, which is used for many type of navigation or tracking various type of jumbo jets, or you wanted to track your cell phones or anything. So Galileo satellites is being used. So Galileo satellites are being put at the medium Earth orbit over there. Okay, so the focus is on the navigation part or global positioning system. So we have a Galileo European Global Navigation System, GNNS, which is providing high precision PNT services. What is PNT? Positioning, navigation and timing services. So under that we have a constellations of satellites are there, which are all working together, and they are all connecting with the Earth ground station and receiver, where they are contacting with each other, and they are providing the data with much more accuracy, integrity, and every time the signals are being available over there. Okay, so application, we have a navigation from there. European Galileo satellite is there, which is utilizing PNT services. Okay, so very common is European Galileo system that is being utilized. Okay, so you can see over here how this medium Earth orbit, where multiple satellites are being put, and they work all in collaboration, and they provide much more accurate and integrity based information over there. Okay, and how Galileo in India, so India is also taking the help of this Galileo navigation system. So in India we are using this medium Earth orbit for our aviation purposes, for our transportation, like including cars, trucks, in which we have all GPS signals are there. GPS devices are being utilized. Galileo signals are being utilized sometimes for route guidance and everything. Then agriculture, we are utilizing Galileo precision positioning capabilities during that time. Okay, so farmers in India are employing Galileo enabled devices for precision planting, irrigation scheduling and yield monitoring. So how we are utilizing this Galileo constellation system for our varied type of applications, which are all being listed here. Even during the time of emergency system, we are utilizing emergency Galileo system or GPS system, we are all utilizing. Okay, so for location tracking, timely assistance and distress situation and telecommunication, obviously we have a constellation of satellites are there, which we are utilizing for telecommunication purposes also. Okay, so here you can see till 1000 kilometer we have a LEO orbit, at 37,000 we have a GEO orbit, and between all this we have a medium Earth orbit is there. Okay, now we are moving towards the polar orbit and sun synchronous orbit. So normally whenever we say polar orbit and sun synchronous orbit, so we will go by first polar orbit. Okay, polar, as the word suggests, like if we have this surface of the Earth is there, so we have these poles are there. Okay, we have a poles from north to south or south to north, that is the pole, that is one poles, and that is vice versa that we are utilizing. Normally they are the LEO Earth orbit. Okay, low Earth orbit, that means between 200 to 1000 kilometers the satellite is being placed. Like here you can see direction from north to south or south to north, altitude between 200 to 1000 kilometer, and they offer global coverage of satellite because they passes from different part of the Earth surface during each orbit. Okay, so we are utilizing this orbit especially for Earth observation satellite and weather monitoring and surveillance, because they have their ability to cover different latitudes and longitudes. Okay, so satellite in polar orbit usually travel the Earth from north to south rather than west to east, Okay, so roughly they pass over the Earth polar orbit. Okay, so satellite in the polar orbit do not have to pass through the north and south pole precisely. Okay, it is not like that they have to precisely go to the north and south pole. No, they can have a deviation of 20 to 30 degree, and still they are can be called as polar orbit. Okay, so they have between 200 to 1000 kilometers. They are there, and they are normally utilized especially in earth observation satellite, weather monitoring and surveillance. Okay, in India we have Indian remote sensing satellites are there, right, of ISRO. They are placed in the polar orbit, like Indian remote sensing satellite 1A that was launched in 1988 was India's earliest remote sensing satellite, which they have put in the polar orbit. Obviously there are a lot of applications are there: agriculture, monitoring, forestry and urban planning. Okay, so this we have already did. Okay, I think this got. Next we are moving towards the sun synchronous orbit. Okay, as the words say, sun synchronous. Okay, so they are again a specific type of polar satellite only, where the satellite maintain a constant angle with respect to sun. They are synchronized with the sun. Okay, so why, what will happen, what is the benefit of that? So this ensure that the satellite passes over any given point on the Earth's surface at a same local solar time at each orbit. Okay, during each time, like if the satellite is, because this sun synchronized orbit is always will look like a same fixed position relative to the sun. That means if the satellite is visiting certain time at certain local time, like if 1 p.m. the satellite is visiting Delhi, next day also 1 p.m. the satellite will visit Delhi. Okay, passing from the city every day at noon, exactly like that. Okay, so this means that the satellite will always observe a point on the Earth if it constantly at a same point. Okay, so if any point is being continuously monitored, like if we say like we have a ice cap is there in Himachal. Okay, in Himachal Pradesh we have this big ice cap is there. Okay, at 1 p.m. on 8th May we have this position of the ice cap. Next day 1 p.m. on 9th May again the satellite will come, and if we are watching that the ice cap has slowly melted, this part got little bit melted. Okay, so we will be able to exactly get like what changes happen within the day during that time, like earlier 1 p.m. and today 1 p.m. is there any changes happening? So satellite scientists can find out with the help of satellite the images, and they can compare the images like how over the change of time the thing has changed. Like if vegetation is there, okay, vegetation is there in May month we were having this. Okay, then we will able to June month we will able to compare with that. Okay, so we have a data of May every day same point, and then we have a data of June same day same point. We will be able to properly compare this data. Okay, so sun synchronous orbit is again a polar type of orbit where the satellite are traveling over a polar region. They are synchronous with the sun, which means they are synchronized to always be in the same fixed position relative to the sun. This means satellite always visits the same spot at the same local time. Okay, this means the satellite will always observe a point on the Earth constantly at the same time in the same day, right? So this is because if you wanted to monitor a area by taking a series of images of certain places across many days, weeks, months or even years, then it would not be very helpful to compare somewhere at midnight and then at midday, right? So you need to take each picture similarly as the previous picture. That means if you are taking the picture in 12 noon, then next day also you should have a picture of 12 noon. Therefore, scientists use images series like these to investigate how weather pattern emerges, to help predict weather or storms, weather monitoring emergency like forest fire, flooding, or to accumulate data on a long-term problem like deforestation, sea level rise, ice cap melting, okay, like that. So often the satellites in the sun synchronous orbit are synchronized so that they are in constant dawn or dusk. This is because they will be constantly riding on the sunset or sunrise. Okay, so they will never have the sun at an angle where the earth shadows them, right? So a satellite is a sun synchronous orbit would usually be an altitude around 600 to 800 kilometer, around 600 to 800 kilometers. They will be normally have their setup over there. Okay, at 800 kilometer, it will be traveling at a speed of 7.5 kilometer per second. Like if they are at 800 kilometers, so they will be traveling at 7.5 kilometer per second. So here we can see we have a 3 orbit: geostationary, they are aligning with equator; low earth orbit, okay, they can have a different inclination like this. Okay, sun synchronous, they are synchronized with the sun. Okay, north south pole. Got it? So here constant lighting, Earth observation satellite. Here in India we have a Cartosat satellite is there, which is developed by the ISRO. This has been pushed under the sun synchronous orbit that was launched in 2017. So it is operating in a sun synchronous orbit around 505 kilometer, obviously, right, in the polar, in the in our normal low earth orbit. This sun synchronous satellite is being put, and it is providing high resolution images of certain place at a particular time of every day, whether rural development, whether land expansion, whether agriculture land expansion, flooding, or whatever it is that they are monitoring. Okay, now we are moving towards the transfer orbit. What is the meaning of transfer orbit? So now what is the meaning of transfer orbit and geostationary transfer orbit? So transfer orbit is a type of a special kind of orbit where we are making the satellite to move from one orbit to the other orbit. Okay, you might have heard regarding our Mars orbiter mission, right? Mars orbiter mission is there. Under that, first of all, we have put one satellite at our Earth orbit. Then we have slowly raised the orbit of that Earth, of that satellite. Then again we have raised the orbit of that satellite. Then again we have raised the orbit of that satellite. You might have seen Mission Mangal movie. In that they have shown that how at various stages we are raising the orbit of the satellite, and once the point come, we have fired the satellite to Mars. Okay, so this is what called as transfer orbit. So when the satellite are launched from the Earth and they are carried to the space, they have various launch vehicles are there. So the satellites are not always placed directly on their final orbit. Okay, first of all, the satellite is placed on a transfer orbit. Okay, where so what is the meaning of transfer orbit? Transfer orbit is an orbit where by using relatively very little energy from our own motors, the satellite or spacecraft can move from one orbit to the other. Because if you are directly transferring to a satellite to the desired orbit, it will take a lot of energy and lot of effort. So what we are doing is that we are putting in a low transfer orbit, then slowly we are raising the height of that. Okay, so what will happen with that? This allows a satellite to reach, for example, a higher altitude like geostationary or satellite without actually needing the launch vehicle to go to that altitude, because that will require much more effort. So this is like we are taking a shortcut. We are putting the satellite at a particular orbit, and slowly we are raising the orbit by simply just firing the engine of the satellite. Okay, so like this, like taking a shortcut and reaching geostationary, geosynchronous or geo orbit in this way is an example of one of the most common transfer orbit, that is geostationary transfer orbit. Okay, so orbit, we know that orbits have different eccentricity, like the way they are moving. They can have a circular, they can have a elliptical way of movement, right? So in a perfectly round orbit, if you are doing proper perfect round orbit, the satellite is always at a same distance. Okay, if we have a proper round orbit, okay, like if this is Earth and we have a perfect round orbit, so from every point the satellite is at the equal distance. Okay, the satellite is always at a same distance. So but on a highly eccentric orbit, the path look like a ellipse. But sometime what will happen if this is a work and if we are doing like this, okay, this is called elliptic way, right? So if we have a highly eccentric orbit or elliptical orbit, the satellite can quickly go from being very far to a very near Earth's surface depending on the satellite in an orbit. Okay, so in transfer orbit, the payloads, what we are sending with the satellite, used engines to go from an orbit to one eccentricity to the other eccentricity. Okay, so which puts it on the track of higher or lower orbit, whatever we need. So once the rocket lifts off, when the rocket lifts off, the launch vehicle makes its way to the space following a line. Okay, at the target destination, the rocket releases the payload or satellite, and which put the satellite in a elliptical orbit. Okay, right? So this point farther away from the Earth on a blue elliptical path, and this apogee and perigee will be coming to place. Okay, so this is how the whole process of transfer orbit normally works. Okay, so for transfer orbit, we should know at which altitude we have to send. Like we have a geo transfer orbit is there at 35,786 kilometers. So first of all, we do not normally direct put at this level. We try to increase the level bit by bit. Okay, so based on the eccentricity, we are like first we have this eccentricity, then we have increase the eccentricity, then we have further increase the eccentricity, right? So orbit that have different eccentricity indicate the degree of circularity or ellipticity. Okay, if we have a highly eccentric orbit, so it will result in a huge variation in the satellite distance. Sometimes satellite comes very closer, sometimes satellite go very far away. Okay, based on that, so we need to do engine adjustment. Okay, we need to fire the engine, okay, from one orbit to another. If we wanted to transfer the satellite, we need to fire the engine. Okay, we have to utilize onboard engines of the satellite to modify the orbits. Okay, because rocket will be falling to the Earth's surface, so we will now have that satellite with the engine over there. Okay, so we can adjust the eccentricity, and then satellite can move from lower orbit to the higher orbit or higher orbit to the lower orbit, whatever is needed. Okay, then payload deployment and orbital adjustment. So once the liftoff has happened, okay, so once the liftoff happened, you might have seen there is a yellow line to reach in the spaces there. So the satellite moves towards, the rocket moves in a yellow line, right? So upon reaching the target location, the payload is released on a elliptical transfer that is called blue line. Okay, so the payload is released onto a blue line, and once at the apogee of this orbit, apogee means the farthest distance, the payload fires its engine to circularize its orbit, okay, or in order to get the desired altitude that we wanted. Okay, so we are utilizing our whole this process in Indian regional navigation satellite system that we call it as NAVIC. Okay, so there are a lot of ways like how we are increasing the altitude. Similarly, Mangalyaan, we have utilized that. Even our Chandrayaan mission also we have utilized, because most of the countries are there in our of the world, they are sending their mission in 1 day itself or 2 days itself, but we have taken 4-5 days to reach to the moons. Okay, we have taken a lot of days to reach to the moon, just because we are slowly increasing the orbit, okay, in order to, so that our fuel should also not get consumed and we will be able to get it easily over there. Okay, and there are a lot of countries in the world, those who have a lot of money, they just simply fire the rocket towards that main target itself. Okay, so but India, we utilized all the customized way, so that slowly we should work on it. During the time when Chandrayaan 3 wanted to land on the surface, Russia also sent his rocket to launch, or to their rovers and lander wanted to move to the southern pole, but Russia space mission got failed and India space mission got successful. Okay, in that. Now we are moving towards the Lagrange point. Lagrange point or Lagrangian points are there. Now what is the meaning of Lagrangian points that are there? Okay, so we know that for many spacecraft that are being put into the orbit, some are very close to the Earth's surface. Okay, so being too close to the Earth can disrupt their mission. So as I told you that if the spacecraft or a satellite that are being put too close, it can disrupt sometime the mission of for which it is intended. Okay, and even at more distance orbiting such as geo. So for example, like if we wanted to do some kind of space-based observation, okay, like telescope, right? We have a Hubble space telescope is there, then James Webb telescope is there, right? Here if you write here Hubble telescope or James Webb telescope, we have Aditya Aditya L1 satellite that we have sent. We have sent it to Lagrange point 1, right? So if there is any of the satellite for, like if we are doing for a space-based observation, whose mission is to photograph the deep dark space, okay, so being very next to Earth will be highly detrimental because Earth itself releases lot of visible light and infrared radiation, so which will prevent the telescope from detecting any faint light like distant galaxy that is coming from anywhere. Okay, so photographing dark space with a telescope next to our glowing Earth would be a very hopeless task. Okay, because you cannot photograph anything of a dark space when you have a too much light coming from your own planet, right, in a broad daylight or whatever it is. So we need to place these satellites and observation satellites at a much larger distance, so where they should not get interfered by any type of lights or infrared radiation from the Earth. That is why Lagrange point, L point, came into place. Okay, so this Lagrange point, what I call it as, is named after a Italian French mathematician that is called Joseph Louis Lagrange. So he discovered that in 1772. That means there are specific point in the space where gravitational force of two large bodies becomes equilibrium. That means neither they are attracting, neither this is attracting. So there it is a stable situation that is created over there. Okay, so Lagrange point or L point allow for orbit that are much farther away, over 1,000,000 kilometers, and they do not orbit Earth directly. They are very specific points far away in the space where the gravitational field of the Earth and the Sun combines in such a way that the spacecraft or anything that is orbiting them remain stable and can thus be anchored relative to the Earth. That means you are anchoring that something over there and you are keeping it relative over there only. So if any of the spacecraft was launched to other point in space very distant from the Earth, we know that they would naturally fall into the orbit around the Sun, and those spacecraft will soon up ending far away from the Earth. Okay, so we will not be able to do communication or anything like that properly. Instead, a spacecraft launched to these special L points. Okay, so in these L points, the spacecraft or satellite remain fixed or remain close to the Earth with very minimal effort without going into a different orbit. So the most used L point, that is Lagrange point, that we call it as, it is L1 and L2 are the most widely used point. These L1 and L2 points are most utilized points are there, and they are both 4 times farther away from the Earth than the Moon. That means around 1.5 million kilometers, that is L1. compared to the geo orbit that is 36,000 kilometer. So L1 point is 15 lakh kilometer, that is called as 1.5 million kilometer. That is approximately 1% of the distance of the earth from the sun. Okay, because earth is around 15 crore kilometer, right? Okay, so many satellites, like if we go by many European satellites like SOHA, LISA Pathfinder, Sun Earth L1 point, Planck, Plato, James Webb telescope is there. They are all being and the antenna telescope are will be, so in the future they will be put onto the L2 point, because slowly L1 point is also getting filled up, because there is too much traffic that is happening at the point L1. So slowly this point is also getting used up. So there are 5 points: L1, L2, L3, L5. So these are the places which are providing a fixed position to the satellites for deep space research. Okay, so we can put Lagrange points are not typically used for communication satellite, but we can understand the dynamics of that, and based on that we will be particularly finding out like where exactly we can put our satellite in the geostationary orbit. This will help in finding out like if this is a Lagrange point and this is all working over here, so at what places our geostationary satellite can be put in order to have a better telecommunication, better broadcasting and internet services. Okay, then future space exploration, Mars mission is there. We have our Aditya L1 mission, though L1 means Lagrange point 1 we have already sent, right? Then we have a space debris management. Okay, so Lagrange point are also used very importantly in the space debris management effort. Okay, so we have a lot of space agency, European Space Agency, NASA is there, JAXA is there. They are all looking forward like how we can utilize the Lagrange point. Okay, so Lagrange point can serve as a location for future space debris collection. That means we can collect the space debris over there, and if possible we can dispose of that space debris at these points. So this is again require a much more technological feasibility in the coming future. Okay, now we are coming into the satellite. Satellites means what are the type of satellite that we send. Okay, so there are various applications of the satellite. Okay, so based on that application we have 13 type of satellites are there. We have astronomical, we have biosatellites, we have communication satellite, we have earth observation satellite, navigation, military satellites are there, then space stations are there, crew spacecraft are there, recovery satellites are there, then solar power satellites, then miniature satellite, tether satellite and weather satellite. So under the astronomical satellite, astrosat mission that we have sent, right? We can call it as Aditya L1 satellite also we can call it as. Okay, so they are observing the celestial sources in different way, length and pathway. So Aditya L1 also we can put over here. Communication satellite, everybody know GSAT, INSAT, all are being launched by our ISRO, right? Then earth observation satellite that we call it as EOS, earth observation satellite that we send. Okay, here you can see there are a lot of earth observation satellite that we have sent. So these are the latest one that we have sent. Okay, I have taken the data of the latest one. Okay, so we have taken this from the ISRO, right? So here you can see that Indian remote sensing satellite, that is 1A, that has been launched in 1988, is a remote sensing satellite, and we are having a constellations of the remote sensing satellite. Okay, and along with this remote sensing satellite we send lot of instruments on board which have a various data they correct diversified, especially spectrally and temporally. They provide us data in all the places. So these satellites are utilized in agriculture, water resources, urban planning, resource development, mineral prospecting, environmental, forestry, ocean resources, disaster management. So if you see the last one is 44 and 43, that is Earth Observation Satellite 07 and Earth Observation Satellite 06. Last was sent on February 10, 2023. Okay, so you can see here they have written the rocket through which they have been sent. So all the type of rocket we will be also understanding. Normally satellite, small satellite launch vehicle, sometimes polar satellite launch vehicle. Okay, for the launch of the satellite we do not require geostationary or GSAT or GSLV satellite, because we have to send it into the polar orbits and LEO Earth orbit. So there is no need to provide a very powerful satellite, very powerful rocket. So PSLV does the main work out of it. Okay, then Earth observation satellite is over. Navigation, we have a Navik, okay, IRNS, then GPS system is there, then Galileo system is there, then military satellite, which are the satellite which are especially sent to which can be utilized for military purposes, right, during the time of disaster, during the time of any kind of war that is happening. So military satellites can be utilized, and these military satellites will be also providing the satellite phone connection. So if you wanted to remove any kind of cell tower connection or internet, so you can contact still with the help of a satellite phones. Okay, then there are space station, ISS, International Space Station, we are creating, we have already created over there. Okay, and then we have a spacecraft that are going on recently. Government is focusing on Gaganyaan mission, for which 3 astronaut have been already selected. Then we have a recovery satellite, which is the recovery satellite is still at a very starting stage. Okay, so these are the satellite which will be launched especially to recover the various type of satellite from the space. Then we have a solar powered satellite. So India hasn't launched solar power satellite, yes, but its own shows interest in space-based solar power as a potential future energy sources. Okay, then miniature satellites are there, like CubeSat, very small satellite of length of inches or centimeters, like even the private institutions or private colleges are sending these satellites with the help of a payload in the form of in the rockets, okay, for demonstration purposes. Then we have a tether satellite. Okay, so India don't have any kind of tether satellite, but we are still collaborating with the world. So whenever we say tether, what is the meaning of tether? A tether satellite is a type of a satellite in which we are utilizing a tether, like connecting the satellite with the help of a tether. Okay, so it is a satellite connected to another by a space tether. Okay, then weather satellite, INSAT satellite are there, remote sensing satellite are there, which are focusing on weather monitoring capabilities, and they are also helping in contributing the weather forecasting and disaster management, right? So here we have already done regarding the Earth observation satellite. Right now we are moving towards a very important topic regarding the satellite launch vehicle, SLV. Okay, so here we will be talking about the rockets which India utilizes and recent mission that India has sent regarding that. Okay, so we go by that satellite launch vehicle. Under that we come with the first one, SLV3. That is the first thing that comes into our mind. So if we know satellite launch vehicle is the first program for India's own satellite launch vehicle, it was a work of APJ Abdul Kalam. It was a work of APJ Abdul Kalam in developing the satellite launch vehicle 3. Okay, it is India's first experimental satellite launch vehicle. Okay, it is all solid stage, so there is no liquid stage. It is all solid stage fuel, 4 stages vehicle, having a weight of 17 tons and have a height of 22 meters, and it can place 40 kg payload. Okay, so satellite or whatever the instrument that you wanted to send, it should be up to 40 kg, and it can only reach up to a low Earth orbit. Okay, so SLV was successfully launched in July 18, 1980s from Sriharikota. Okay, when Rohini satellite, RS satellite, Rohini satellite 1 was placed in the orbit with the help of satellite launch vehicle. So this makes India a 6th member of an exclusive club of a spacefaring nation. Now India is a sixth country who can send its own satellite. Okay, so SLV employ a very open loop guidance system, okay, to flight along a predetermined trajectory. Okay, so the first experimental flight that they have sent was on August 7, 1979. Okay, that was remained partially successful, and they have done much more launches like in 81 and at 1983. Okay, so this success of our satellite launch vehicle for the first time has given way forward for various other launch projects such as augmented satellite launch vehicle. This is just next to the satellite launch vehicle, and then PSLV, our most celebrated launch vehicle, and geosynchronous satellite launch vehicle. So here you can see down, this is SLV3, launched in 1980, and they're taking the Rohini satellite. You can see here in 79 we have done a experimental flight SLV3. Then Rohini satellite one has been set up, and in 81 we have Rohini satellite D2, and 83 Rohini satellite D3 has been placed with the help of satellite launch vehicle. Okay, now we are moving towards the next part of it, that is called as augmented satellite launch vehicle. Okay, so during that time it has a lift of weight of 40 tons. It has a lift of weight of 40 tons. That means it is much more above that, right? More than double of the satellite launch vehicle. Satellite launch vehicle SLV has a lift of weight of 17 tons, and augmented satellite launch vehicle will be having of 40 tons. Okay, and they can take it is 24 meters tall and have a 5-stage, all solid propellants are there. Okay, there's no liquid propellant, all solid propellants are there which will be fueling this rocket, and they can take orbiting a 150 kg class satellite into a 400 kilometer circular orbit, again a LEO orbit. Okay, so they can take a payload of 150 kg, that is 3 times more than the satellite launch vehicle. Okay, so they have taken all the experience from there, and they are now able to properly make the whole process with the help of strap-on technology, inertial navigation, and heat shield mechanism and everything. So the first ASLV program, 4 developmental flights were conducted. First flight took place on March 24th, 1987, and second on 13 July 1988. Okay, so here you can see this is the type of a rocket where 5-stage rocket it is. And we can see here at 87 first ASLV D1 was launched, and then ASLV D2, so both mission became unsuccessful. When in 1992 and 1994 ASLV D3 and D4 they become successful with SRO SSC2 payload they are taking with that. Okay, orbiting SRO SCC2, that is weighing 106 kg, that is rotating at a height of 400 kilometer in circular orbit. Now comes the most celebrated of the Indian rocketry system, that is satellite launch vehicle, that is polar satellite launch vehicle. Okay, so this is in the 3rd generation. First and 2 we have already discussed. Okay, so in this it is the first time we are equipping with liquid stages, because the satellite launch vehicle and augmented satellite launch vehicle both were using solid propellant, but in polar satellite launch vehicle we have come up with a liquid stage, and its first successful launch was happened in October 1994. Okay, and with this the PSLV become much more reliable, much more versatile workhouse over there. Okay, and this has launched numerous Indian and foreign satellite and foreign customer satellites into the orbit, and we know that Chandrayaan 1 mission in 2008 and MOM mission, okay, Chandrayaan mission of 1 of 2008 and Mars orbiter mission of 2013 the rocketry or the satellite launch vehicle that has been utilized is Polar Satellite Launch Vehicle. Okay, so the launch of PSLV C-48 marked the 50th launch of the PSLV. Okay, so this is the most reliable satellite launch vehicle that India is having, and this satellite, because of its versatility, is known as the workhouse of ISRO. Okay, because this is continuously delivering the satellite in a consistent path at the low Earth orbit, particularly the Indian remote sensing satellite, without any kind of difficulties over there. Okay, so that means it is much more reliable than previous satellites, and now this satellite is being utilized to like various launching satellite into geosynchronous orbit and geostationary orbit like IRNS constellation. Okay, so now this satellite launch vehicle, that is PSLV, has now even equipped with sending multiple payloads. Like from single rocket we can release multiple payloads along with that, and the payload performance of the vehicle and mission is, we can see, it has been providing much more challenging all the way possible, but the PSLV is becoming reliable and everything, and the PSLV is much more becoming reliable, versatile and affordable in global launch market, which provides their customers with a low launching cost. Okay, Polar Satellite Launch Vehicle. You can see here like Polar Satellite Launch Vehicle XL configuration, gross weight is 320 ton normally in the starting, and height is around 44.4 meters, and the diameter is 2.8 meters. Okay, 4 stages are there, have a multi satellite launch capability and multiple orbit capability. Okay, so lift off mass along with all the fuel, it is 320 tons. Okay, much more than any other. So if you go here, you can see the augmented satellite launch vehicle, it is the lift off weight is 40 ton. Okay, but now we have a PSLV which has a lift off weight of 320 tons. Okay, so under that we have 4 modes are there for PSLV: CA, PSL, DL, QL and XLs is there. Okay, so first flight of PSLV happens in September 20, 1993. Okay, and it can also take the payload to sun synchronous polar orbit 1750 kg. That means 1.7 tons of the payload it can take. Okay, that is why it has a title of the workhorse of ISRO. Okay, it can take 1750 kg of payload to sun synchronous polar orbit 600 kilo at a 600 kilometer altitude. Okay, and it can even take to sub geotransfer orbit of 1425 kg. So this is showing a unmatched reliability which is utilized by launch market of satellite of geosynchronous and geostationary orbit like that. Okay, so this is Polar Satellite Launch Vehicle. So 4 stages are there. During the starting stage, there is a fuel, that is HTPB, that is being utilized. Then at second stage we have a UDMH and N2O4 fuel that is being utilized. Okay, we have a Vikas engine. You know Vikas engine? We might be knowing that this Vikas engine from like Nambi Narayan. Okay, he has developed the Vikas engine. Then we have a third stage. Under that we have a motor that is being there, S7. Again, it is utilizing fuel, that is HTPB. And at the fourth stage, it is utilizing MMH and MNO as a fuel, and engine is 2 into PS4. Okay, so this is all the technical things. Okay, these are all the technical things are there. You just have to remember it is a 4-stage launch vehicle, and you just remember, like in the second stage we utilize the Vikas engine under this. Okay, now these are the recently launched India's satellite with the help of Polar Satellite Launch Vehicle. That means the 60th one, it is like PSLV C-58, launched in January 1st 2024. Okay, with PSLV DL. ExpoSat satellite. Okay, and you know Aditya mission, that is India's solar mission. Okay, India's solar mission is also launched from the PSLV C57 rocket. Okay, on September 2, 2023, Aditya 1 payloads are there. Right, I hope everybody knows that. And last here we have launched Telios and Earth observation satellites, all are being there, which are being utilizing Polar Satellite Launch Vehicle for transfer. Okay, here you can see the starting one. Okay, here I have seen I have given you so these are the starting 10, and these are the when the PSLV has started their operation. Okay, PSLV D1, which got unsuccessful, and after that it has historically been one of the most successful satellite launch vehicle, through which we have sent our remote sensing satellite, OceanSat satellite, Kalpana 1 satellite, Cartosat satellite. All these things are being sent. Okay, so there are around up to 60 satellite launch have been happened with the help of Polar Satellite Launch Vehicle. Now we are moving towards the geosynchronous satellite launch vehicle Mark II. So with the help of so this geosynchronous satellite launch vehicle Mark II, under that we have developed our own vehicle. So we are sending and launching our communication satellite in the geotransfer orbit using the cryogenic third stage. Cryogenic means whenever any satellite is working on a, like when we are keeping the fuel at a very cold temperature at a liquid temperature, because liquid hydrogen and liquid oxygen has to be kept, and that has to be put at a very low temperature, then only they remain liquid at that temperature. So we have to deal at a very low temperature. Okay, so earlier we were taking the help of the Russia in this technology cryogenic stages, but we have developed our own indigenous cryogenic, and we have also inducted from January 2014, and with the help of GSLV D5 rocket mission, we have started utilizing our own a geosynchronous satellite launch vehicle with the help of a cryogenic stage. Okay, and from January 2015 the vehicle has even achieved the 6 consecutive success are there. So various stages have got changed. Okay, so we will be helping in operationalizing the 4th generation launch vehicle, but you just have to focus on like this stage, and this vehicle is utilizing the cryogenic stage. Okay, this vehicle is utilizing the cryogenic stage, and now we are able to launch 6 consecutive missions since 2014. So first of all, we should know what is the specification of this vehicle. Okay, GSLV Mark III. Okay, we put it as GSLV Mark II. Okay, right, so height of this is 51.73 meter. 3 stages it is, like 3 stages in which this satellite is going to work, and liftoff mass is 420 tons, very high. First flight was in 2001, and first flight with indigenous cryo was happened in January 5th 2014. Okay, so earlier we were using the cryogenic technology of Russia, but our own cryogenic technologies that we have utilized is with this engine from January 5th 2014. Okay, so it can put a payload in geotransfer orbit of with 2250 kg of the satellite. Okay, geostation GSLV primary payload like INSAT classes communication satellites from geostationary orbit, and they are placing it into the geosynchronous transfer orbit, that is GSLV, with the help of GSLV. Then if we are transferring the payload at LEO orbit, low earth orbit, so we can transfer 6000 kg of payload. That means 6000 kg of any payload can be transferred to the low earth orbit. Okay, and GSLV capability of placing up to 6 tons in the low earth orbit. That means it is providing us with putting much more heavier satellite or multiple satellites at a time. Okay, so these are the 3 stages. During the first stage, you can see here it is having HTPB fuel that is being utilized over here. Okay, so here they are writing that this stage 1 will be burning for 100 seconds. Once the 100 seconds are over, the second stage will come into place and it will burn for 150 seconds. Here they will be utilizing US-25 and N2O4, and here again we will be utilizing the Vikas engine, right? Very important. And at the last third stages, we will be utilizing the cryogenic stage. Okay, this is the upper stage, cryogenic stage. Here we will be utilizing liquid oxygen and liquid hydrogen. Okay, so they work at a cryogenic stages and they will burn for 814 seconds. Okay, so these are the 3 stages of geosynchronous satellite launch vehicle Mark 2. Okay, from 100 seconds they will, first stage will burn, the second stage will burn for 150 seconds. Here Vikas engine we will be using, and at the third stage we will be utilizing our liquid oxygen nitrogen, or this is the cryogenic stage. Okay, this is the cryogenic stage. Okay, so here these are the important mission, geosynchronous satellite launch vehicle missions that has been there. Okay, so like from GSLV D1, GSLV D2, and all these missions were there in the starting, for which the remarks were not there. Okay, but if we go by January 5th, here the successful mission, so we were having some successful mission, but from here exactly GSAT 14 satellite. Okay, GSAT 14 satellite we have utilized for communication. Okay, that's been launched with the help of geosynchronous satellite launch vehicle Mark 2. Okay, then after that we are having much more successful mission, 1 2 3 4 5 6 7 8 9 important success. But here we got a failed mission under that in 2021. Okay, when we are transferring the orbit to the geosynchronous transfer orbit, so Earth observation satellite, the mission got unsuccessful over there. Okay, then after that we were normally utilizing the communication satellite and INSAT satellite and navigation satellites over there. Okay, so geosynchronous satellite launch vehicle has little bit shaky adoption and shaky careers, right? That what we call it as. Okay, now we are coming into the geosynchronous satellite launch vehicle Mark 3. Very important, Mark 3. So with the geosynchronous satellite launch vehicle Mark 3, that is LMV3, we can see here it is a 3-stage vehicle. It is a 3-stage vehicle in which we have a 2 solid strap propellant on motor, that is, and 1 liquid core, and the last one, that is a high thrust cryogenic core that is there. Okay, so this S200, that is the solid strap that is on motor. These solid motors, these are the largest, which is among the largest solid booster in the world, which are holding around 204 tons of solid propellant. Okay, right? And the liquid L110 stage is using twin liquid engine, which is having 115 tons of liquid propellant, and C25 cryogenic upper stage is configured with a fully indigenous cryogenic engine, that is CE20, which is having a propellant of 28 tons at the last stage. Okay, so here if we see, it has achieved a heavy lift weight of achieving 4000 kg, that is 4 tons of spacecraft into the geosynchronous transfer orbit in a cost effective manner. Okay, so this is a 3-stage vehicle like that. Okay, here we can see height is 43.5 meter, vehicle diameter is 4 meter, that means slowly it is increasing. Lift 3 stages are there, which we have already discussed, 1 solid, 1 liquid, and then at an upper stage, that is a cryogenic stage is there. 640 tons is the lift of mass. Okay, at geo transfer orbit 4004 tons, and low earth orbit 8000 kg, that is 8 tons. Okay, and geo transfer orbit 4 tons, and at low earth orbit 8 tons of the satellite or any device can be placed over there. Also, that means we can now place much more heavier payload up to earth orbit of around, low earth orbit of around 600 kilometers. Okay, so slowly the capacity is increasing. So here you can see, here it is having core stages, where liquid stage which is there, which is utilizing 2 Vikas engines. Okay, you can see here we have a 2 Vikas engine, we can see over here, which will be utilized and having 115 tons of That is a core stage that I'm talking about. That is a second stage, right? Then solid stage is there, which is S200, which is having 205 tons of HTPB. Okay, so it is having a height of 25 meter, and at the last we are having cryogenic stage, which is having fuel of 28 tons of liquid oxygen and liquid hydrogen. Okay, this is the last stage. Okay, like that they are utilizing. So here are the list of geosynchronous satellite launch vehicle GSLV Mk3. Okay, so we have launched around, like from December 2018, we have around 7 launches that have been there, where in the December 2014 we are checking the crew module atmospheric re-entry experiment, that is CARE experiment. We are utilizing this rocket. Then GSAT-9, that is communication satellite, and Chandrayaan 3 recently has been sent with the help of this LMV3. Okay, that is geosynchronous satellite launch vehicle, on July 14, 2023 has been sown with the help of this LMV geosynchronous satellite launch vehicle. Okay, so you can see very big programs like Chandrayaan 2, Chandrayaan 3, a crew model, or are being utilizing this type of rocket for their launch. Okay, now we are moving towards the small satellite launch vehicle. So these are the very small, if you wanted to have a if you have a very small application purposes are there. So for that, small satellite launch vehicles are there, so that we should not utilize the heavier satellites, and if we have to put at a very small like altitude or something like that. So again, these are the 3-stage launch vehicles are there. Okay, 3 solid propulsion stages are there. 3 solid propulsion stage and a liquid stage based on the velocity trimming is there. Okay, terminal stage at the top stage. Okay, 2 meter in diameters. Okay, it is 2 meters in diameter and 34 meter long. Lift of mass is 120 tons. That means a very less lift of mass is there. That means it is just requiring to send a satellite at a very lower orbit. Okay, so 3 solid propulsion stage, liquid module as a terminal stage. Okay, so they can launch 500 kg satellite into a 500 kilometer planar orbit. Okay, so why people utilizes? They are low cost, low turnaround time, flexibility in accommodating a multiple satellite, and based on the demand it can be launched within few days itself. Okay, so you can send like single or multiple, like nano satellite, micro satellite, or mini satellites. Okay, and single satellite up to 500 kg in 500 kilometer planar orbit. Okay, so if we wanted to send like three multiple satellite ranging from 10 kg to 300 kg into 500 kg planar orbit. So normally any country who wanted to send their satellite and they don't have proper budget and they wanted to send it at very small orbit, so we will be utilizing the SSLV, small satellite launch vehicle. So here you can see the small satellite launch vehicle is having 3 stages. Stage 1, in which again they will be utilizing HTPB solid fuel. Okay, then at stage 2, then again HTPB, and third stage we all the way I told you, like this is a 3-stage solid propellant rocket is there, and at the last there was a velocity trimming module is there. So it is having a 50 N biopropellant thruster. Okay, so they will be utilizing MMH and MON3 as a liquid fuel. Okay, as a liquid fuel. During the time there is a velocity trimming module that has to be there, where satellite has to be placed. Okay, so this is for you came here and within 5-6 days you wanted a launch and you have a satellite with you, so this can be done easily. Okay, so some of the SSLVs that has been launched recently was in like Earth Observation Satellite 07 and Earth Observation Satellite 02 has been sent with SSLV, small satellite launch vehicle, and in D1 and D2 missions that are there. So we only have our launch till now, our own satellite, because that has to be sent at a lower orbit, and that we don't want to waste our money on the heavier rockets. Okay, now we have a RLV-TD, reusable launch vehicle technological demonstration. So since last 2-3 years we can see lot of demonstration is going on. So this is one of the most widely and demonstrated technology and a very challenging endeavor that ISRO is taking. Okay, how they can reusable the launch vehicle so that they can enable low cost access to the space. You know, SpaceX is having that technology. Okay, SpaceX is having that technology where they can just send the rocket and then they can re recover their own rockets. Okay, so this reusable launch vehicle similarly has a configuration is similar to that of a aircraft. Okay, so they combine both the complexity, first of all, of a launching vehicle, okay, of a launching vehicle and of the aircraft. So first of all, it will go up and then it will flow down as a in the form of a aircraft. So all these experiments are going on. You can see right now in the TVs also, government is like ISRO is trying to do all the launch vehicle testing, and you can see that aerial TV is running on the runway. Okay, so there are a lot of technologies are being utilized over here, and in the future we will be seeing the missions based on that. We will be sending our crew mission also with the help of reusable launch vehicle and launching our satellite with the help of launch vehicle. Okay, so the main objective is hypersonic aero thermodynamic characterization of a wing body. That is, we have to test this. Okay, then evaluation of navigation guidance and control measure when it is on the flight. When it is on the flight, we have to measure all the things. Then integrated flight management, that's once it is being done, once it is coming down back, whether all the flight controls and everything are working properly or not. Okay, then there is a thermal protection system evaluation has to be checked. Okay, has to be checked because during the time of re-entry from into the atmosphere, there is a lot of friction. There is a lot of friction that happens because of the air. Okay, because of the air friction, so normally the things get burnt up. Okay, so how the thermal protection is going to work properly, that also has to be checked with this relaunch vehicle your technological demonstration. Okay, then we are coming into the scramjet engine demonstrator. Okay, so what is this scramjet engine? Okay, so the first experiment regarding the air breathing and propulsion system was conducted on August 28, 2016 from Satish Dhawan Space Center. Okay, so it has taken a flight of 300 seconds, where after that the vehicle touched the Bay of Bengal around 320 kilometers from Sriharikota. So during whole the test flight, the flight is able to properly contact and make a contact with all the ground station, all the station that are there on the sea. Okay, so with the help of this flight technology, we can see up to the ignition, how the engines are taking the breathing of the engines are happening, how the engines are working at a supersonic speed, and how this intake mechanism of the fuel that is working. Okay, so this scramjet engine was designed by our ISRO using hydrogen as a fuel and oxygen from the atmosphere. Okay, so they will be sending the hydrogen along with that, and they will be taking oxygen from the atmosphere as an oxidizer. Okay, normally in the rocket what we send the liquid hydrogen and liquid oxygen, but here we are only sending the hydrogen, and this engine will be taking the oxygen from the atmosphere itself. Okay, so this scramjet engine will be having a hypersonic flight. Okay, they will testing the advanced technology version of this whole flight. Okay, so we will be also so there is a special what we call it as objective for that. So the main purpose of the scramjet engine that the ISRO is developing is because the scramjet engine can propel vehicle to hypersonic speed. Okay, which is very important for space exploration, at the same time at a defense application. Okay, so at the same time this rocket don't have to carry along with the extra fuel, because the oxygen they will be taking from the atmosphere, so it will be allowing more and more efficient travel and can significantly reduce the cost of launching the object into the space. Otherwise, every time we have to provide oxygen, liquid oxygen every time. Okay, but there are certain challenges that are associated with the scramjet engine. So one of the most important challenges is that the scramjet technology is achieving sustainable operation at hypersonic speed, okay, which has involved overcoming the drag and act against the vehicle motion. So ISRO aim to demonstrate an engine that can produce more thrust than drag. Okay, so these are all technical words. Okay, so it is just like that. We wanted to produce a rocket system which can provide much more reliable and which can provide with much more reduce and more efficient travel, and more significantly reduce the cost of launching any object into the space. Okay, so here if we can see, yeah, here. So the solid rocket booster scramjet engine at a supersonic condition. ATV is carrying a scramjet engine weighing 3,275 kg at a liftoff. So this is like we have tested in 2016. Okay. So this is all for today. I hope guys you all have enjoyed the session. We will be coming out with the next space part 2 in the next class. So we will be discussing a technology which we will be understanding the major projects that ISRO has taken. So that will be in the space part 2. So this is only a technical topic today. We have discussed only a basics of launching the satellites and orbit and various type of orbit. So we will be coming out with one more important lecture where we'll be discussing all the important projects that ISRO is running. So till then, thank you so much. Bye bye, take care and have a good day.